So first I want to cover sets and notation. All this will be familiar to many of you in the higher levels. This will pertain to all my classes. I'll post this in all levels. So we kind of want to start off on the same page, more or less. So first, set notation. I want to talk about what we call set builder notation. Okay, so set builder notation looks something like this. You'd say, so if you wanted to talk about a piece of a number line, so you have a number line, and we basically want to break down subsets of the real numbers. So suppose we wanted to go from, say, -2, and then say we're going to approach negative infinity. So we're going to go here, and you want to go this direction. Okay, so we want to talk about that. So often what books mostly do is, up until like calculus at least, they would use interval notation. So your interval notation would be negative infinity to -2. But the set builder is what you start using more and more of to describe sets. Move that down a little bit. So it would look like this. It's the set x, and the vertical bar is such that x is less than or equal to 2. So that's the way you would write that. You'd read it like this. You'd say, in quotes, so this is red. The set x such that x is less than or equal to 2. Okay, so that's how long you'd have to write that out. So what you end up getting is condensing all of that, all those words, into a small description. And a lot of math is like that, the higher you go, actually. All right, so let's continue. Let's break down the number line into its constituents. So first, we often talk about this set. It has a name. 1, 2, 3, etc. 4, 5, 6. That is the set of natural numbers. Okay. Then if you throw in 0, you get the whole numbers. Okay, and we don't always refer to them as those names, but that's what you would name them. We usually say, we can say like positive integers, negative integers, non-negative integers. That's what we usually say in the books. So for the integers, they use a z. So that's now when you throw in the negatives. So it'd be -3, -2, -1, 0, 1, 2, 3, etc. Like that. Okay, so those are the integers. So I'll be using mostly integers or natural type of notation. So you'll see as we go what that's going to look like when we describe different sets. So using set builder, we can then talk about the integers and then the rationals. So I'm not going to make a big deal out of this right now, but if you take any piece of the number line and you start at, say, I don't know, 0, and here's 1, what's the next rational number? Right, what's the next number that's rational after 0? And the answer is actually there is none. There isn't any. Anytime you take another number, you can always split it in half. Just added those up, divide by 2, and it's halfway in between. You can do that indefinitely. So there's an infinite number of numbers between any two numbers. Okay, so not going to get too much into that, but that's a lot of set theory kind of stuff. So rationals, you got to say P over Q such that, and then you would say what P and Q are. P and Q are integers. And what about that denominator here? What would you say, of course? And Q does not equal 0. So we want to take that notation a step further, introduce what P and Q are. So P and Q here, those are integers. So we want to say that they are in the set of integers. So what do you say? Many of you, I'm sure, know this. P, and you use this symbol, is an element of the integers. So that symbol, well, both of them, but I'm just trying to describe the symbol. So that symbol means element of. So what you would write that set as instead, the rationals, you'd say Q, and then you put a little line on the side like that, is equal to the set P over Q such that P and Q, commas and are elements of the integers, and so it has, both have to be true. The denominator Q does not equal 0. So that's how you would say rational numbers. Okay, so those are rationals. Okay. All right, so then the next set are irrationals. Or irrational, I'll say irrationals. Literally means not rational. So basically cannot be written in this form as a fraction. That's literally what it's saying. So if it can't be written as a fraction, then it's irrational. So cannot be written as a fraction. Okay, so that's one way to think of them. And for now, I'm just giving you examples. I'm not going to get too much into detail with that. So for example, and I'll talk about this abbreviation later. Okay, so for example, and what are they? I'm sure many of you know, right? You got pi e, and those are actually transcendental, but I won't get into that either. But those are different type of irrationals than these next couple. Square root of 2 is another irrational. And any sort of root that's not perfect. Fifth root of 7, I just throwing a bunch down there. And then you get into sines and cosine type stuff. You know, if you did like sine of 1. Sine of a special angle would give you... could give you a rational number, but sine of some weird number like sine of 1, that's irrational as well, and transcendental. So these guys are what we call transcendental numbers. So basically not roots of polynomials and things like that, but I won't get into that. Okay. So next is after irrational. So if you put the not rational and rationals together, you get all the reals. So the real numbers, what we stay in most of the time. So real numbers, we will describe those as well. We use capital R with a line on the side for real numbers. So it's equal to, sometimes you'll see just negative infinity to infinity. Okay, so that's all of them. So you could write something like this, I suppose, if you wanted to. So let me see what I did here. So you can describe it like that, all left to right. So this would be negative infinity, infinity on the right. So you go left to right. So negatives are left, positives are right. Okay. If you wanted to describe Well, let's get into complex first. Then we can talk about the complex numbers. So that looks like this. The set A plus BI such that A and B are reals, and I is defined to be the square root of -1. Okay, so those are complex. You would have seen that in college algebra or any sort of algebra, like second level algebra. You would have talked about complex numbers. Not going to get into the complex plane, but there is a whole field of study on that. It's called complex analysis. Okay, so let's take a look at an example. So true or false? 4 is an element of the set -2 to 5. Okay, and that would be a true statement. So my point to that is that when you say something like this, that's an actual sentence that's either true or false. It's a statement that's true or false. So if I said something like 3 is an element of the set 4 to 8, including 8, that is a false statement. So element of gives you, it's not, so a set is like a thing, but when you put it in this form, you're actually creating a sentence. It would be quite long. So you're communicating a lot of stuff in a short amount of distance, short amount of word, notation wise. Okay, so that's all I got on sets. So all that's on sets. Let's continue now to some notation that you need to know. Just more logic type notation. So this notation may have seen before, maybe not. Upside down A means for all or for every. Meaning is the same, of course. Backwards E, like that, means there exists. And then we talked about the such that. So this such that usually used or reserved for the the sets, and then this one is reserved more for wrong. No, that's right. More for like writing something out. So that means such that, or the rest. What comes next is true or follows. So such that. Sometimes you'll see me abbreviate it like this, ST, but it comes up a lot, so we'll use that. This we'll use as well. The EG means for example. Sometimes I'll say, define something and then say, for example, here you go. And then another one is the IE. That means that is. Okay, and then let's continue. So, there was one more thing on sets I wanted to show you. So if you have something like this, so this all means the same thing. So all means the same thing. Excuse me. Okay, so if I say negative infinity less than t less than infinity, that's a longer way of writing just t is an element of the reals. So this notation I'm going to prefer. It's much simpler to write. Another notation would look like this. So if I said t is an element of 0, infinity, then that's another way of writing t is an element of the positive reals. So if you put the plus sign, that actually means that set. So not 0. So positive reals means they're positive. If I say non-negative, then you can basically union those together. So you could say R union the set with 0 in it. And that would include 0. So I didn't get into unions and intersections, but something you may want to keep an ear out for. Some abbreviations I will use are for solutions. Like here's the solution or solutions is SOL, and then you like the TION, you use like an N, so that'd be solution or solutions, either way, whatever it pertains to. Then we have equations. So you might guess similar E, Q, and then just you leave off the vowels basically. But that's a Q. Then let's talk about, we'll use some Greek letters often in math. So these are often used. In math. So I could just show you the Greek alphabet, but actually, frankly, some we don't use a lot. These are the ones that come up enough. I want to give you them right now. So you have delta, capital and lowercase. That's delta. We use that. Obviously, you've seen pi before. Let me not do that. Okay, so that's pi. Epsilon. Looks like that. So you may want to look up the Greek alphabet, but these are the ones we use mostly. I'm sure you've seen theta. And then you have phi. We use mu. Capital sigma, probably seen that. That's capital. Or just capital or upper, I'll just say upper, lower. It's easier to write it out. So that's upper. And then you have the lowercase, looks like that. That's also sigma lower. And then you have alpha, beta, gamma. That's alpha, beta, and gamma. First 3 letters of the Greek alphabet, actually. And there's probably more, but those are the ones we use quite a bit. So just keep an eye out for those. You're looking at how we write things up in the book. And if there's anything else, we'll define them as we go. Okay, so I'm not going to test you specifically on any of these, but we will start using this notation right away in all of my classes. Okay, so write down any questions you may have and ask me.